Okay, good afternoon. Growing renewable energy. We believe that demand response and demand-side management, demand-side flexibility can highly contribute to growing renewable energy. And therefore I want to present to you today the perspective from an aggregator. Well, some might have already heard some of these solutions, and because I've already seen some faces also at other events, this shows that that you think it's an interesting story. Thank you for that. But also, it could be that some of the slides you might have already seen, but still do not hesitate to ask questions immediately after the presentation. So, the aggregator's perspective. Some of the slides might be, because I didn't know whether it was in English or in Dutch, so some of the parts of the slides might be in Dutch and some in English, but I read on the internet a few weeks ago that new services, new solutions were introduced into the market. And not the energy market as such, but all types of markets. And there I read the largest taxi company does not own any own vehicles. Does anyone know which company this is? Uber. But also in other contexts, the world's largest popular media owner creates no content himself, and the world's largest accommodation provider doesn't own any real estate. And this is in other contexts. This is it has nothing to do with the energy sector, and therefore I started wondering what could be the next thing. What could be the next thing if we look at the energy sector? What can we learn from the energy sector, from these developments we see, from these new solutions that are created, these new services that are being developed? And maybe it can be that one of the most innovative solution, or very important solutions that are provided in the energy sector could be delivered by companies that do not own any own generation facilities themselves. Just like an Uber which doesn't own any vehicles. Aggregators do not own any generating facilities themselves, but again, they provide services in this context. So, and that is what we believe, that we can provide new services, new solutions to problems that we see emerging in the energy market, but that these services can be offered without owning any facilities ourselves. What is the problem? Well, the problem in the energy sector is actually not that complex. And if people start talking about the energy sector like 20 years ago, I think this must be the most boring sector that you could imagine. The only thing that we needed to do was to maintain the balance between generation and demand. And we've been doing this for many, many years, so this was really not a big challenge at all. But we see today that on the one hand, investments have to be taken, or investments have to be made. And then the question is, which types of investments? Long-term investments? Well, that requires a long-term horizon, which is not that easy in the energy sector, and also with regulation, which might have a long or very important impact. So determining the optimal investments is not that easy anymore. On the other hand, what is the optimal operation of the grid? We have these new technologies. Can we use them? How can we use them? How can we use them in a smart way? So we see where the energy sector was quite a boring business in the past, we see today new challenges that make it much more interesting, which also requires new solutions. Why demand response? From a system perspective, well, to support the growth of renewable energy. But you can also look at it from the perspective of customers. Customers that, well, have some flexibility, as we say. And this flexibility can be used. It can be used to support the growth of renewable energy, to support the security of supply, the secure operation of the grid. Well, and if you then do a quick SWOT analysis on why to participate, why to offer flexibility services, then we see, well, there are consumers today having a large consumption profile. Well, this means that electricity is a huge cost in their operation, and making it interesting to optimize it. You can optimize it by going for energy efficiency activities. You can try to negotiate with your supplier to find this 0.5% reduction, but then it's very often end of story. And there are new opportunities. Well, we see there are price fluctuations. We see that there are new services, system services that are offered or that can be offered by consumers themselves. But participating to these new services, well, is not always easy, because if you want to participate, offer flexibility, you have to keep this flexibility available. So the availability is quite often an issue, and some companies have different sites, multi-site companies, which makes also the optimization of the flexibility more and more important element. And then we also see, well, if you try to negotiate with your supplier, you see more and more you're, well, it's an optimization behind the comma, because a large share of the invoice is determined by grid tariffs. And some new tariffs, because of strategic reserves, are added to this. So there's also a threat that tariffication, that the electricity bill continues to increase without being able to do something about it. So there is definitely some opportunity, something that can be done. Something that can be done, well, depending on the problem you want to solve. And in the beginning of the presentation, I said, well, at the left you have these short-term problems, and at the right you had the investment problems, or defining the optimal investment. Well, let's first have a look at the short-term. Can we contribute in short-term to a better operation of the grid? Well, it depends. There is, of course, definitely a need because we see some variable renewables that are being integrated into the grid. We see also more distributed generation, and we see some new consumers that also being integrated. Even some storage, which could become valuable at the near future. So there's a need, because if we connect all these devices, let's call it just devices, energy consuming or producing devices, if we just connect them to the grid, and if we do not try to communicate with it, if we don't try to monitor it, steer it, then we will have quite a dumb grid. Grid which might need to be over-dimensioned, which is not a smart thing to do. So, if we want to do it in a smart way, then we need to communicate with it and to steer with these new sources of flexibility. And this is not a new point, well, or not new objective to do, because it has already been done for many years. Because Elia, the transmission system operator in Belgium, has in the past already created system reserves. And these system reserves were created just with the purpose of balancing the grid in short term. So whenever we saw a problem on the electricity grid, being the outage of a generating unit, being the outage or a trip of an interconnection line, at that moment we saw an imbalance, a system imbalance in the grid, which needed to be resolved. And therefore Elia contracted system reserves, primary reserves, secondary reserves, tertiary reserves, with some capacities. And these were different types of reserves, like spinning reserves, which were quite fast, also spinning reserves, secondary reserves, which can respond in minutes time, and tertiary reserves like the cold, the standing units, which need to be started up if they want to offer extra flexibility. So whenever we see a shortage, extra power can be injected into the grid. But then, of course, we saw that there were some very, very small peaks in consumption, or very, very small shortages, which only happened in a very limited number of time. And if we also want to contract reserve or build generation capacity to resolve these problems, it will become quite expensive. And therefore, the TSO, Elia, realized that there is also the opportunity to reduce consumption from the large consumers. Because we do not want to happen this quite often, they are positioned at the end of this, what you could call technical merit order. So if there is a shortage, we will first activate these reserves before starting offering reserves from these consumers. So these indicated in green are all provided by, or to the most extent provided by generating units, and then in gray is flexibility that is mainly offered from consumption level. And because we do not need to resolve this problem that often, it's quite interesting to use facilities where it's already invested in, like an operational facility which consumes a lot of electricity, and then we just curtail it or shut it down whenever there's the need for it. Let's give an example. So if we look at the flexibility, then we look at the consumer side. If we look at how to valorize it, we look at the reserves. So if we want to valorize the flexibility, well, the consumer is consuming a certain level. Whenever we see a problem, they can reduce their consumption. They can drop the power that is taken from the grid. And there are different options to do so. This can be done by starting up local generation or by shutting down local consumption. And the result is every time that the offtake from the grid is being reduced. If we start up local generation, it can even be the case that power is injected partly into the grid. And then in order to allow us to participate to these services, well, there was a need for a clear design, the product design of this flexibility. Because we knew these primary, secondary reserves, they existed already for many years, and there were very clear characteristics of what these power generating units were capable of. Now the question is, what is this smart consumer capable of? And then there was a design determining that it could be activated 40 times per year. So 40 times per year, there could be a request to reduce consumption. And then there could be a reduce of consumption for up to 2 hours with a minimum period between consecutive activations. So it was quite important to determine this clearly, that also operational, from an operational perspective, from the perspective of the smart consumer, that they knew what they signed for, that they knew that, well, we can deliver flexibility services, but they can only be activated in such circumstances. This is a type of solution for the short term. For the long term, there was also a need, because we saw that investment, well, it was very, very fast. Now you've seen all of it, so. No, okay. Try again. The investment scheme in Belgium was not that easy on the one hand, and also the availability of these generating units we have today is also not that easy. Doel 1, Doel 2, Tihange 3, Tihange 1, availability of Doel 3, Tihange 3. So we have seen problems in the last months for almost every unit, whether it was on maintenance, whether it was a transformer which was out, whether it was a discussion on the life cycle of these units. So there is a high technical risk, or well, there is a technical risk, whether it's higher than other power units, we do not know. Well, I don't know. But there's also a huge regulatory risk. What is the availability of these units for the next winter period, for the next years? This has a very negative impact on other investments. No one is willing to invest in a generating unit which might be redundant, because all at once, if we give a permission for Doel 3 Tihange 2, then there is an additional available capacity in the market of 2 gigawatts. So who will invest in such an unstable regulatory scheme? So this is dangerous to use. Okay. Not only the risk on nuclear, but also we see some issues on these gas-fired units. First, it was announced that 1,600 megawatts more or less were ready for closure, but then, of course, some of the larger players in Belgium changed their mind on some of these units, which again creates additional additional uncertainty into the market. Also, renewables pushing out other technologies, as well as the CCGTs, which are these flexible, efficient gas-fired units. So, issues on the generation side, requiring the need for other solutions. Again, we see that the available generation portfolio we have in Belgium was not capable of, or is today not capable of dealing with the needs we have in the market. We saw it in short term to balance the grid, to balance the renewables, but also in long term, there is not enough generation capacity available. And therefore the solution was the development of the strategic reserves. Strategic reserves, it's been created for about 1.5 years ago. First delivery period was last winter, and currently they are about to take the decision on the capacity that needs to be contracted for next winter period. The design was somehow different, whereas the balancing reserves, which are the reserves for short activations, always require a short response time, less than 15 minutes. Here we have much more time, up to 5 plus 1.5, 6.5 hours before actually the need to reduce consumption. So you get the signal for determining the need to reduce consumption, and then still some preparations can be made, some changes in the production scheme can be done before actually the reduction of consumption is required and before the load needs to be reduced. So this means, because there is a larger period before activation, this means that more processes can be introduced into the scheme. But they only need to be available for the winter period. And again, whenever we see the need for it, for instance, in the morning we see that we will not be able to capture or to provide enough power for the evening peak, then the signal will be provided in the morning required to reduce consumption for the evening peak. What is our role in this story? Well, we are an aggregator. What does an aggregator do? The first thing they do is try to find the flexibility. Where is the flexibility? Some processes, the low-hanging fruit processes, well, that's quite easy. Everyone in the company knows, well, we can shut down some processes, such capacity is made available, which is quite easy. But very often it's more complicated. We see a total consumption profile, and behind this total consumption profile we see different processes, and some of these processes, here indicated in blue, are flexible. And this means that they're not always continuously available. This also means that some of them can be activated, in the meaning that they can increase consumption, but also reduce consumption. But there are other characteristics of this flexibility as well. So not only upward and downward, but also what is the speed of it. Some of these processes, flexible processes, can be activated for demand response, in seconds time, some in minutes time, some in hours. Then there might be a cost. Well, if there is a process where, say, 20 people is working, and you ask for consumption reduction, you stop this process, well, these 20 people can go cleaning. That's what they say. That's what the cost is, because these people are no longer operational. They can no longer provide these added value at these normal processes. So there is a cost involved. And this analysis is what we do for each customer. Let's take the well-known case of a cold storage. Well, first you think, well, we have this flexibility all the time available. For example, this is the consumption profile, giving quarter hours for one representative day. You see this profile, so key process is cooling, so you say more or less 400 kilowatts can be reduced. Well, might not be that true, because cooling is maybe only done overnight. So what happens if they have already done some optimization, some load shifting, that only the green indicates cooling consumption. So they avoid cooling during the day, because typically day-night tariffs result in a higher price during the day. So they push all cooling activities to the morning and the evening peak. This means that there is hardly any flexibility, downward flexibility available during the day. So during the day, we cannot reduce consumption. We can only do it during the night. On the other hand, there are possibilities to increase consumption during days with overgeneration, for instance, of solar power, maybe today. And then there are other processes. Let's take a shredder. Well, they start quite early in the morning. So what they do is they just take old cars or old furniture or whatever, and they just shred it till they get this residue. But this is the typical consumption profile of these sites. What does it mean? They start quite early in the morning, before 6. At 6 they start with their shredder and have quite high consumption profile, because shredding is a very energy intensive activity. But there's no activity during the night, so during the evening this will drop. But this of course creates opportunities for us to balance and to combine these both processes. These two sites, separately or individually, are not capable of offering flexibility to the market, but by combining these different sources, we can create a guaranteed block of flexibility, which is always available and which can always be activated when there's the need. And this is what we do, not for one site, we do it for many sites, like cooling activities, water activities, local generation, shredding activities. And by combining these sources of flexibility, we come to a balanced portfolio when the unavailability of the one is resolved by the availability of the other. And this is what we do for all our partners, which we then try to connect to our portfolio. So we determine what are you capable of doing, tertiary reserves, strategic reserves, other reserves. And given this flexibility, we connect them to our platform. By connecting them to our platform, we are capable to receiving signals, say, from Elia, and whenever there's a need, we provide these signals, we communicate these signals to our different partners. Maybe one site might not be available, okay, then this problem is resolved by another site. Maybe for one type of flexibility, one site is not capable of doing it or delivering it, then other sites will be activated. And there's the last opportunity. We see, well, we can offer flexibility to Elia, the transmission system operator, which can provide us signals which we can then distribute to our different partners. But the alternative is responding to electricity prices. We see electricity price fluctuations throughout the day continuously. So, whereas Elia only activates us whenever there's a huge problem, close to blackouts, close to large imbalances in the grid, electricity prices fluctuate continuously. So for some sites which only want to be activated a few times per year, it's interesting to be available, keep yourself available and respond to Elia signals. But for other sites which are capable to respond continuously, which are capable of continuously optimizing the consumption, they can respond continuously to electricity prices. This can be BELPEX prices, this can be imbalance prices, and this can be at whatever price level that we see in the market. This requires modeling. Why? Because very often today we see the low-hanging fruit capacities that are already available, which we can activate quite easily. But alternatively, there are also some processes which are more critical, which are more difficult to activate, to see which flexibility is available, when can we activate it, what are the different levels, constraints on, for instance, water reservoirs, what is the lower level, the upper level. But this one is interconnected with this one is interconnected with the other one. So it's not just the fact that you can shut down one pump without impacting another site or another type of flexibility. And this is monitored, this is modeled, and this allows us, by doing modulation, this allows us to capture the flexibility and only activate it when the grid allows us, or when the customer allows us to do so. Shown in a different way, we see, well, what are the minimum levels and maximum levels, what happens if we activate, deactivate, how can we use and operate the flexibility or the reservoir between these upper and lower levels. Can we increase, can we reduce consumption? This is what we monitor and follow. So to summarize, we look at the consumers on the one hand. Can they activate flexibility? How fast, how long, how frequent? Before we start implementing and effectively valorizing the flexibility in the markets. Valorizing the flexibility in the market, we can do it to resolve short-term problems, price fluctuations, or long-term problems. Short-term problems, these were these system reserves. Long-term problems were the strategic reserves we discussed, but also the price fluctuations like imbalance prices and BELPEX prices. To conclude, we see that the energy market and the current operation of this energy market is stressed in short term as well as in long term. We need to integrate the renewables, growing the share of renewable energy. We also see a problem in the long term, having the generation capacities available. Therefore, we see that demand response can be a solution. It has already been proven that it's a good solution. And therefore, we provide our added value to identify the flexibility and also to valorize it in the markets. That was it. Are there any questions? Yes.
We're talking about Elia, which is a transporter, but can this system of price fluctuation can be brought all the way up to the end consumer, like a household, because then you have an intermediate party, which is the
Well, if we talk about the problems in short-term and long-term, ELIA reserves and strategic reserves, these are created by ELIA, and this is to resolve the problems of ELIA, system imbalance or shortages in the long term. And there indeed the counterparty is ELIA. ELIA will contract these reserves for their purposes, for their main activities. Looking at price fluctuations, well, that is there is ELIA not involved. We sometimes say, well, if you want to valorize the flexibility as maybe show as these balancing reserves or as the strategic reserve, you talk about a regulated valorization of flexibility. You offer it to the regulated party, which is ELIA. ELIA is regulated. The CREG determines what are the capacities that you need to contract for balancing for strategic reserves, which capacities you need to contract, and they, as a regulated party, will be the counterparty to contract these reserves. The prices, price fluctuations on BALPACs and imbalance prices, well, these are for the market. This means that everyone who is active in the market, who is exposed to these prices, can respond to it. Many consumers, however, choose not to be exposed to these prices. If we choose, like a large consumer can choose for day and night tariff, this means that they choose not to be exposed to these prices. But for some of them, today the question is, well, is it not, maybe it's interesting to become exposed to these prices because I have the capabilities to valorize the flexibility by adjusting my consumption. And that's then the question is how to change these the invoicing scheme that they have and the exposure to the energy prices before valorizing this flexibility. So here the counterparty is ELIA directly, makes it quite clear on the products and how they are determined and how they need to be contracted. Here the prices are the way they are, so whenever they fluctuate there's an opportunity, but your contract should expose you to these prices.
They don't fluctuate so often.
Well, if you have a day-night tariff, this means they do not fluctuate. But, well, they fluctuate between day and night.
Yeah.
But for some customers, they choose to be exposed to these prices, these high fluctuating prices. For instance, there are many CHP owners which say, well, I can activate my CHP when the price is high, producing more electricity, and I can shut it down whenever the price is low, because, well, then the value of this electricity I produce as a byproduct for my heat, well, then it's only a low valorization. And these sites, they choose to have such a contract and to be exposed directly to these imbalance prices. And these prices, they fluctuate quite strongly. They can be between, like the one example I gave in this graph, I think they go to minus 200. We saw already prices to minus 300. We see it almost every day, no, maybe not every day, but several times a week we see prices of zero. Almost every week, up to 2 weeks, we see negative prices. This means consumers are being remunerated to consume more. On the other hand, we also see price spikes, upward price spikes, spikes to 100, 150. And ELIA has now introduced a scheme that prices can spike up to 4,500 euros per megawatt hour, which was a few times in the news before the winter, because it was the scheme that whenever the strategic reserves are activated and we see a shortage on the electricity market, then prices are arbitrarily set at 4,500 euros. If you then have the capability to reduce your consumption, you're remunerated at 4,500 because you do not consume it anymore and you sell the energy at that price.
What do you have to do to change your meter to this?
Well, if you have a meter like we have at home, then it's not possible to contribute. So for residential consumers today, it's not yet possible given the current regulatory scheme. Industrial sites which have an automated meter, having 15-minute metering, well, they are capable of doing so already today. And that's now the debate. Should we go for smart metering, where we can see what is being consumed, which volumes and so on? Or are there alternatives which allow us to still monitor and see what has happened, but we do not need to go for this expensive smart meter, but still seeing what is the flexibility that is baked into it. And that's now the debate: do we need smart meters to go for flexibility, to activate flexibility at the residential segment as well. Okay, no more questions? Okay, thank you.